Good morning, students. Today we are going to see the applications, advantages and disadvantages, and various types of electrochemical machining. Previous class we have been seen about what is electrochemical machining principles and constructions, working principles, and analysis of a material removal and tool material and tool design installations, and what are the electrolytes used for different materials, and what are the essential characteristics of electrolytes, and what are the surface finish mainly depends. Today we are going to see the applications of ECM. To machine complicated profiles like jet engine blades, turbine blades, turbine wheels, drilling small deep holes such as in nozzles, machining of cavities and holes of irregular shapes, machining of blind holes and pockets such as in forging dies, machining of odd materials and heat resistance materials. Characteristics: material removal technique based on Faraday's law of electrolysis. Work material: difficult to machine. Tool materials: copper, brass or steel. Voltage: 5 to 30 volts. Current: 50 to 40,000 amps. Material removal rate: 27 millimeter cube per second. Electrolyte: 20% NaCl solution in water, mixture of brine in sulfuric acid. Surface finish: 0.2 to 0.8 microns. Tolerance: 0.005 mm. Specific power consumption: 7 W means watts per mm cube per minute. Advantages: the metal removal rate by this process is quite high for high strength, temperature resistance (HSTR) material compared to conventional machining process. Wear and tear of tool is negligible. Machining is done at low voltage. Intricate and complex shapes can be machined easily through this process. The machining work surface is free of stresses. No cutting forces are involved in the process. High surface finish of the order of 0.2 to 0.8 microns can be obtained. Very thin sections such as sheet metal can be easily machined without any damage. It is an accurate process and close tolerance of the order 0.005 mm can be easily obtained. No bursts are produced and this process can be easily automated. Toughness and brittleness of a material has no effect on the machining process. Limitation and disadvantages. Limitations. Sharp internal corners cannot be machined. Post-machining cleaning is needed to reduce the corrosion of the workpiece. Tool design is very complicated and it requires cut and dry method to achieve the final shape. Complicated control is needed for the maintenance of high tolerance. Disadvantages. Non Non-conducting materials cannot be machined. Consumption of power is nearly 100 times more than in turning or milling the steel. Machining process is comparatively slow. Investment Initial investment is quite high. More space is required. To vary the tool feed rate and supply of electrolyte, constant monitoring is needed. Difficulty in designing a proper tooling system. The difference between EDM and ECM. In EDM, the workpiece is submerged in a dielectric fluid. In ECM, workpiece need not to be submerged in electrolyte. In EDM, tool wear take place. In ECM, no tool wear take place. In EDM, control system is required. In ECM, no control system is required. In machining cannot be done at low voltage. Machining can be done at low voltage. MRR is slow compared to ECM. MRR is high compared to EDM. Less energy is consumed. More energy is consumed. Next, another one important is electrochemical grinding, which is called ECG. Introduction. The material which cannot be easily shaped due to their extremely hardness or high tensile strength can be grouped or ground by using electrochemical grinding process. Example, cemented carbide, hardened steel, etc. The principle of electrochemical grinding or electrolytic grinding. In electrochemical grinding method, the work is machined by the combined action of a electrochemical effect and conventional grinding operation. But the major portion of the metal, about 90%, is removed by electrochemical effect. Constructions of ECG process. The schematic arrangement of electrochemical grinding process. It consists of a workpiece, work table, grinding wheel, spindle, DC power supply, electrolyte pump, motor for pump, nozzle, filter for incoming electrolyte, and reservoirs for electrolyte. The grinding wheel is mounted on the spindle, which rotates inside the suitable bearing. The workpiece is held on the machine table in suitable fixtures. The table can be moved forward and backward to feed the work or to withdraw it. The grinding wheel and a spindle are separated from the machine by using an insulating sleeve. Sodium nitrate, sodium chloride and potassium nitrate with a concentration of 0.150 to 0.300 kg per liter of water are usually used as electrolyte. The electrolyte from the reservoir is pumped and passed through nozzle in the gap between the wheel and workpiece. A constant gap of 0.025 mm is maintained between the grinding wheel and workpiece. The grinding wheel is made up of fine diamond particles. These particles are slightly projecting out from the surface and come in contact with work surface with very little pressure. The grinding wheel runs at a speed of 900 to 1800 meter per minute. The workpiece is connected to positive terminal anode of battery and grinding wheel is connected to negative terminal of the which is called cathode. Working principles. Working. A mild DC voltage of about 3 to 30 volts is applied between the grinding wheel and workpiece. Due to the applied voltage, the current flows through the electrolyte with positively charged ions and negatively charged ions. The positive ions move towards the grinding wheel cathode while the negative ions move towards the workpiece anode. The electrochemical reaction takes place due to this flow of ions and it causes the removal of metal from the workpiece. It can be seen that the workpiece is fed against the rotation of grinding wheel and the metal is removed from the workpiece surface by the simultaneous abrasive action and electrolytic reaction. In fact, 10% of the workpiece metal is removed by abrasive cutting and 90% by electrolytic reaction. Disadvantages. Initial cost is high. Power consumption is high. Metal removal rate is lower than the conventional grinding. Non-conducting materials cannot be machined. Prevention. Preventive measures are needed against corrosion by electrolyte. Maintenance cost is high. Since the tolerance achieved are slightly low, the work piece need final abrasive machining. Applications. It is best suited for very precision grinding of hard metals like tungsten carbide, tool tip, high speed steel tool. Cutting thin section of hard materials without any damage or disruption. Next very important one is advantages of ECG. Since the tool wear is negligible, the life of the grinding wheel is increased. This factor is most valid in the grinding of hot metals such as tungsten carbide where costly diamonds grinding wheels are used. In ordinary grinding, there are high wear rates on these expensive diamond wheels. Work is free of surface cracks and distortions because heat is not generated in the process. As compared to the conventional grinding, a very little cutting force is applied to the workpiece. Good surface finish is obtained. Work material is not subjected to any structural changes. Integrate parts can be machined without any distortion. The surface finish produced by this process is varied from 0.2 to 0.4 microns. Accuracy of the order of 0.01 mm can be achieved by proper selection of wheel grid size and abrasive particles. Burr-free and stress-free components are produced. The wheel bond wear very slowly, so the grinding wheel need not be dressed properly. Disadvantages: initial cost is high, power consumption is high, material removal rate is lower than the conventional grinding. Non-conducting material cannot be machined. Maintenance cost is high. Preventive measures are needed against corrosion by the electrolyte. Since the tolerance achieved are slightly low, the workpiece needs final abrasive machining. The last one is ECH. ECH is nothing but a electrochemical honing is similar to electrochemical grinding. That is, the work is machined by the combination action of a electrochemical effort and conventional grinding operation. ECH, however, uses rotating and reciprocating non-conducting bond honing stones instead of a conducting grinding wheel. Most of the metal is removed by electrochemical effort. Advantages: metal removal rate is faster with reduced tool wear. It is about 10 times faster than the conventional honing and about 4 times faster than the internal grinding. Burr-free and stress-free components are produced. Less pressure is required between honing stones and workpiece. Used to machine burred edges. Noise and distortion are reduced. Thank you.